Hi all, welcome to Plus Access for Coding Interviews. This is Coding Interview series, so let's get started. So, in order to really understand how data structures work, we are going to derive each one of them from scratch, starting with the bits itself. So, in this entire series, we are going to cover these much topics from random access memory, binary numbers, fixed with integers, arrays, strings, pointers, dynamic arrays, linked list as tables. Particularly in this video, we're just going to cover only on random access memory alone. So let's get started on random access memory. Like when it's running code, it needs to keep track of variables. Here I'm mentioning variables such as numbers, strings, arrays, etc. So these variables are actually getting stored in RAM. Sometimes we just call it as in working memory or just memory itself. The RAM is not where we used to store files such as MP3, images, video, those things. In addition to memory, that is RAM, there is one more thing concept called storage, which is sometimes called peripheral storage or disk. While this memory or RAM we used for storing numbers, strings, arrays, etc. But the storage we use to store files such as MP3, audios, those things. There is actually a difference between these two. The RAM is way much faster, but it will be having very less space compared with the storage. In your laptops or mobile phones, you can observe this. If you just say laptop, there will be like 500 GB of storage is there, but there is only 16 GB of RAM. In order to understand how this RAM works, you need to think RAM is like a really tall bookcase with a lot of cells, like millions of cells you can think. And then each cell we can have it a numbered with a unique number. We can call this number as an address. We can say it's like a memory address, and each cell can hold to 8 bits of data. That is, there is a new term here. I'm introducing bits. So what is bit? You can think bit as a tiny electrical switch. You can turn it on and off. But instead of calling it as on and off, we can call on as 1, off as 0. So in each cell we can store 8 bits of data. There is one more concept here called byte. That is, a collection of 8 bits is called byte. So from these two things we can conclude the in particular self, in a single self we can able to store 1 byte of data, or in other terms we can call 8 bits of data. Of course, in our computer there is actually a processor which will do all the work. So the processor is actually have a direct connection with memory controller. What this memory controller is will do, actually the memory controller will do the reading, writing from and to the RAM. That is our large tall case. And this memory controller has a direct connection with each and every self, because when we read the first request, we read the address 0, and then again the next immediately we are trying to read the 90,000 memory address. Because of this direct connection, it will be very much faster. It's like very quicker. That's why we call this random access memory. We can able to read the random address right away. And there is one more concept in our processor. It's called cache. Actually, in reality, there will be like series of cache will be there. L1 cache, L2 cache, L3 cache will be there. But we can just picture it as a one bulk of cache alone is there. What's the purpose of this cache is, whenever processor tries to read some data from memory controller, the memory controller what it will do is it will pass the nearby contents to the processor also. Let's just say processor trying to read the address 0, that is this memory shelf, this bookshelf, and what this memory controller will do is it will load all the nearby contents. Let's say up to 4. So up to 4, these nearby contents getting loaded to the cache itself. So whenever the processor next try to read, first it will look into the cache. If it is present there, then it will get data from there itself. Otherwise, it will go uh, it will go to the memory controller. With the help of memory controller, it will look into the large book itself. That is our RAM. So why this cache is needed? Whenever we try to read the sequential memory addresses, it won't look into this RAM. It will be way much faster when you are reading from the cache. That's why when when you are trying to read from the sequential order, the processor will be very much faster compared with the reading from RAM itself. So this is all about RAM. And there is a case, okay, before concluding this, there is a case like if the processor tries to read randomly, let's just say in the first read, it is trying to read the zeroth address, that is this first address, and in the next read, it is trying to read the last one. In the third read, it is trying to read the middle of these two things. In these cases, every time it will be a catch miss for this processor. So it will obviously going to read from the RAM. It will be very slow. So that's why the RAM our processor is way much faster when we are trying to read from consecutive or sequential memory address. So that's it for random access memory. In the next video, we are going to store numbers in RAM or our tall bookcase shelves using binary numbers. Until then, see you. Bye.